Hello everyone, myself Girish P. Today I am discussing about plastic analysis of continuous beam. Introduction of plastic analysis of continuous beam. Plastic analysis provide a method for evaluating the load carrying capacity of structural behind the elastic limit. The continuous beams are structural elements that span multiple supports and are subjected to bending moment and shear force. This analysis is essential for understanding the failure mechanisms of beams under various loading conditions. Basic concept of plasticity. Plasticity refers to a permanent deformation, the deformation that occurs when materials are subjected to stress behind their yield point. The yield surface defines the limit of elastic behavior, and once exceeded the material they can experience plastic deformation. Understanding these concepts is crucial for applying the plastic analysis to continuous beam effectively. Continuous beams overuse. The continuous beams have multiple spans and or they are supported at more than 2 points. The points is allowed for redistribution of moment. This behavior of continuous beams differs to significantly from simply supported beam, particularly in terms of moment distribution. Engineers often use continuous beams to optimize material usage while maintaining structural integrity. Load and moment distribution. Load distribution on continuous beams leads to the varying bending moment their length. The moment distribution can be calculated using methods such as coefficient method or the moment distribution methods. Recognizing how loads are transferred through beams is essential for accurate plastic analysis. Plastic hinge formation. A plastic hinge formation when a section of the beam reaches its yield moment, allowing rotating without further moment resistance. The formation of plastic hinge is a key aspect of the mechanism that leads to the ultimate failure of continuous beam. The engineers can predict the locations of plastic hinges to access the overall stability and safety of the structure. The mechanism of collapses in plastic of continuous beam. The plastic mechanisms of a continuous beam when it occurs through the formation of multiple plastic hinges. The analyzing the mechanism helps identifying the load conditions under which the structure will fail. Understanding the collapse mechanisms is vital for designing safe and efficient structures. Applications of the theorem of virtual works. The theorem of virtual works can be used to calculate the collapse load of continuous beam. These approaches the involving consider virtual displacement and the associated work done at internal and external forces. The utilizing virtual work this simplifies the understanding the plastic behavior in continuous beam. Design consideration. In designing the continuous beam, engineers must consider factors such as material properties, load types, and support conditions. The adequate safety factors are critical when applying the plastic analysis to ensure structural reliability. The compliance with relevant design codes and standards is essential for achieving safe and effective design. Advantages of plastic analysis. The plastic analysis allows for the more economical design by maximizing the use of material while ensuring safety. It provides insight into the post-yield behavior of structures, which is vital for understanding the real-world performance. These methods can lead to more efficient designs comparing to traditional elastic analysis approaches. The advantages of plastic limits are plastic are light in weight, they can be easily molded and have ex- excellent finishing. These processes can vary good strength and toughness. The process good shock absorption capacity. The plastic are corrosion resistant and chemically inert. They have low thermal expansion of coefficient and possess good thermal and electrical insulating properties. The plastic is a very good water resistance and possess good adherence. Plastic is a strong, good and cheap of product. Conclusion. The plastic analysis of continuous beam is a powerful tool in structural engineering, offering insight into load capacity and failure mechanism. Further research may focus on integrating advanced material and construction techniques into plastic design methodologies. The continuous advancement in computational tools while the accuracy and efficiency of plastic analysis in complex structure. The plastic analysis of continuous beam, the increasing the applied load until yield occurs at some locations, will result in elastic plastic deformations that eventually reach a full plastic condition. The full plastic condition is one of the sufficient number of plastic hinges are formed to transform the structure into mechanisms.